Good morning, my students. ECN301 students. I'm here again to upload on that video. Now, I want to say that I reduced the second video that I showed you on utility function. I reduced it to about 4 point something meg. The video was not clear. In fact, it was initially up to 800 and something that I reduced to 440 something. I further reduced it, but it was not clear. I was had to send it like that. But I've learned a lesson now on what to do. I have to take the phone camera very close to what I'm showing to you so that it will not be too blur when I reduce it as much as possible. Now, if you look at this, yesterday we told you that I'm going to show you how we've got 7.5, the S per unit of time or per period of time consumed at which the consumer is at the saturation rate or the maximum point of total utility. Now, so I'm going to show you that. But what I'm going to do is that I'll use another example. Then you can do it yourself. You know, when the consumer is at maximum total utility, the marginal utility will be at 0. This point, the marginal utility is 0, even though you are seeing 7.5 here. 7.5 stands for the S per unit of time. But the marginal utility itself here is 0 because it's intersecting the horizontal axis. Now, even though it is 7.5 units of the commodity that was consumed per unit of time, the marginal utility here is 0. So having said that, let's move on to what we want to talk about today. Now today we're talking about the relationship between total and marginal utility. Now, assume the total utility TU function of a hypothetical individual for good S is given as this. Okay, I didn't write it down, but if you look at this, this is what I'm talking about. It's given as this total utility equals to A plus BX plus CS squared minus DS cubed. Assume that this is what is given. And this is a diagram of the total utility. Please take note that this is just, this point is a little bit of an error. So the rating goes like this and curves down this way. That is total utility. This one below it is not part of it. So if you can draw your own without this, it will be very nice. Thank you. So if you look at this, at this point, the consumer, he will be at the point of diminishing marginal utility. In other words, before the consumer got to this point, the total utility was increasing in an increasing manner. But by the time it goes to the point of diminishing marginal utility, total utility will increase, but it will increase in a decreasing manner. It gets to the maximum at B and then starts diminishing. The total utility starts falling. What will happen here is that as the consumer total utility will be falling at this point, the marginal utility, if you look at the B part of the figure, marginal utility will start falling. Now let's relate them together. If where the consumer total utility is increasing in an increasing manner, it gets to the point of inflection, which is here, the marginal utility will also be increasing until it gets to, it increases, the total utility is increasing in an increasing manner until it gets to be the point of diminishing marginal utility, which is the point of inflection. At that point of diminishing marginal utility, that is where the marginal utility, if you look at the B part, at A prime, the marginal utility will also begin to fall. Now, the total utility, as the monthly utility is falling, total utility will increase in a decreasing manner. It gets to its maximum, and when monthly utility starts falling, that means monthly utility gets to zero. Rather, when monthly utility gets to zero and it starts becoming negative, total utility will be falling. So, and if you look at this, the monthly utility here will be b plus 2x minus 3ds squared. Now, if you see how we're able to get that, see total utility is certainly we assumed initially a plus bs plus cs squared minus ds cubed. Monthly utility is the derivative of the total utility, dtu dx, which will give you b plus 2x minus 3ds squared. All this we are doing a revision of what you should have known earlier. Now, let's look at this with a practical example. Take note that this is assumed to be your note. Whatever I've said that I've not written down, please write down your note so that it will be easier for you to study. So we're going to do the determination of point of diminishing marginal utility and saturation point or saturation rate, as the case may be, of the consumer. Now look at this. Now, given a total utility function, that is t equals 25x plus 5s squared minus 2 over 3s cubed. Determine, Roman figure 1, the saturation rate of consumption. Roman figure 2, determine where the diminishing marginal utility sets in. Now let's take the first one. Sorry, I think I should have put here Roman figure 1. So Roman figure 1, total utility is given as this. To get the marginal utility, you take the first derivative of the total utility, du dt s equals to 25 plus 10s minus 2 over 3 s. What is this? Okay, minus 2 over 3 times, the power here, you bring it down to multiply 3s squared. Reduce the cube here by 1. That's what we did here. That will give us 25 plus 10s minus 2s squared. So, having taken that, you look at this. Since the marginal utility defines the slope of the total utility function, and the slope of a function is 0 at its maximum or minimum point. What this means is that we set the marginal utility equals to 0. So this, we have to set what we got earlier on as our marginal utility to be equal to 0. Now, this is a quadratic equation. So using the quadratic formula, this is the quadratic formula we used. And then from this quadratic formula, we got our a to be minus 2. That's what we have here. A is minus 2 because we have a in the quadratic formula and a here. So our a from our quadratic equation, this a is minus 2. Our b, this b here, in these two places, our b is the coefficient of s, a is the coefficient of s squared, b is coefficient of s, which is 10. Then our c is a constant, which is what I wrote here. So once you substitute and you work out, what you will get is either s is approximately 7 or s is approximately 2. Now, we do not consume negative commodity. Since we do not consume negative commodity, s cannot be negative. We then take s to be equal to 7. Therefore, total utility is maximum when s equals to 7. We obtain the maximum utility of the individual from consuming s by substituting s equals to 7 into the total utility function. So, having done that, what you will get will be the maximum total utility TU will be when you substitute then you will get this 191.33 utils. That's the first part. No, this is not supposed to be B. It's Roman figure. Should be Roman figure 2. What we're obtaining is Roman figure 2. Take note. So the Roman figure 2. So we have to obtain the point of diminishing marginal utility function. Point of diminishing marginal utility. No. To obtain the point of diminishing margin, this is not function. Take note. To obtain the point of diminishing margin utility, this is the same as finding the second order derivative of the total utility function. So the mu dx is equal to d squared tu ds squared, which gives us 10 minus 4s. And setting the mu ds or d squared tu ds squared equals to 0, we will then obtain 10 minus 4s equals to 0. That will give 4s equals to 10. S will be 10 divided by 4. If you break it down, to give you 2.5 or 2.5. So this is the point at which, therefore the consumption rate at which margin utility sets in is at S equals to 2.5. So this is the point at which marginal diminishing margin utility sets in. That is the point where S equals to 2.5. That is very, very important for you to take note of. You can also get the, okay, yes, let me give you that as an assignment. So I would like you to get the margin utility at which diminishing margin utility sets in. You do that by substituting to the margin utility function to get the point at which diminishing margin utility sets in. And you can also get the total utility at which diminishing margin utility sets in. That is a point of inflection. So get two things for me. And just post on the Telegram group. Let's see who is correct and who is not correct. Get the point at which the margin utility at which diminishing margin utility sets in, and also get the total utility or the point of inflection at which margin utility sets in. Two things. Thank you so much. Have a lovely day until we meet again in the next video. Take good care of yourself and stay safe. I love you all. Bye.